All right. Hello, Math 8 Rainy students. This is a little bittersweet for me, but this will be the very last video that you guys will be given for the 8th grade before you guys go off to promotion next week. So without further ado, here we go. Number 1 says, consider quadrilaterals ABCD and EFGH. Are the two quadrilaterals congruent? Yes or no? So 1, you can count the number of squares, or number 2, you can use your patty paper, but nevertheless, the answer is going to be yes. Congruent means it's got the same shape, same size, and obviously in this case it does. And then part B says, if they are congruent, describe what you can do that would map ABCD onto EFGH. So the way I did it is I first just did a reflection across the y-axis, and again, unfortunately I can't show you because I can't show the patty paper on here, but trust me when I tell you that if you reflect across the y-axis, and then after you reflect across the y-axis, you translate or do a translation 4 units up, that will get you from ABCD onto EFGH. For number 2, it's asking which one of these will give you, will map ABC onto A prime, B prime, C prime. Okay? So the only one that would work for this one is going to be the first one, because if you do a reflection across the x-axis, which happens to be here, reflection across the x-axis, right? That will put your new triangle here, right? But because the gray one is simply 1 unit above that, the only one that works is a reflection across the x-axis followed by a translation up 1 unit. For number 3, it says, which pair of figures are congruent based on a 270-degree counterclockwise rotation? So if you take each one of these and do a 270-degree clockwise rotation, remember a clock goes in this direction, just like that, okay? So counterclockwise, of course, would be going the opposite way. The only one that works, and again, you can't really do this without patty paper, so as soon as you get your patty paper, try doing this for each one of these and see which one goes on to which other one, doing a 270 degrees clockwise. And your only answer that you can get for this one is the letter C. For number 4, it says that RST is congruent to XYZ, so they want us to know what is XY. So XY has 2 tick marks. The only one that has 2 tick marks here is this one, which means that this one is 310 feet long. For number 5, it says that a truss bridge has a dimension shown in the figure. If the triangles are congruent, what is a perimeter? Okay, so this is our key word here, perimeter. Perimeter just means the distance around the entire triangle. So from A to B, it's 100. From B to C, it's also 100. From A to D, it's 80. So from D to C, it's also 80, right? So if I simply go and I start here at A, and I go from A to B to C all the way back to D, then I have to do 100 plus 100 plus 80 plus 80. And when I add all those up, the number that I get is 360 feet, which happens to be letter D. So just remember, perimeter is the distance around the object. And in this case, they're wanting us to do the distance around the entire thing, which happens to be the truss of the bridge, which is outlined there. For number 6, consider the following triangles where DAB is congruent to BCD. Determine the measure of BDC. So if I go BDC, that's this one right here, and it's the one that has the 3 arcs. So if you locate on the other triangle, the one that has the 3 arcs, it's that one, 82 degrees. So in this case, that one is just simply 82 degrees. So for number 7, you're just looking at the tick marks and you're looking at the arcs. So essentially is angle P, the one with 3, congruent to angle O, which only has 1, and the answer is no. So I put incorrect. Angle P has, again, 3. Angle N has 3. So are those two congruent? Yes, they are. So I put correct. And then to save myself a little bit of time, I'm just going to go ahead and put the rest of these on here for you because a lot of you guys should be able to figure these out without my help. So this one's going to be incorrect, this one's going to be correct, this one's going to be incorrect, and the last one, of course, is going to be correct. For number 8, it says, consider both of these triangles RST and DEF. It says, are the triangles similar, right? So for RST, if I count the bottom 1, 2, 3, 4, 5, 6, and then I count for DF 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, okay? Has the same shape, right? Not necessarily the same size, but this is going to be a yes. Are they similar? And then it says, if they are similar, then how can we map one onto the other? So again, first we have to find the scale factor. So D to F is 12, and then R to T is 6. 12 divided by 6 gives you 2, which means that the triangle DEF is 2 times bigger than RST. So for this one, we just say dilation of 2. And once you make it 2 times bigger, then you don't need to do anything else because they will match up perfectly for number 8. For number 9, it says use scale factors to determine if quadrilateral C is similar to D. So first things first, cross out A and B because they're not even talking about A or B. They're just talking about C and D. So what I did on my paper is I drew the 2 so that way they were facing the same direction. So down here, all I did is I took the C, right, and then I just made it look like the D, okay, and then I just took the measurement of each part, and then I said this one is a 4, this one is a 3, this one is a 2, this one is a 4, this one is a 5, and this one is a 3. So if they are similar, then they should have the same scale factor all the way around. So you choose any 2 sides that correspond. So for example, I'm going to choose the 3 and the 2, right? So I'm going to choose the 3 and the 2. They correspond. And the number that I get here is a 1.5, right? That's my scale factor, right? Now, if it's similar, then the scale factor should be the same all the way around. So if I choose a second one, let's choose the 4 and the 3. As long as 4 divided by 3 is 1.5, then I'm good. But in this case, 4 divided by 3 is 1.33333333 repeating. So this one is not similar. They must have the same scale factor in order for them to be similar, and in this case, they are not. Okay. For number 10, it's the most recent stuff that we have been doing. We are simply just setting up a proportion. Okay. So proportions can be done a lot of different ways. Just make sure you keep it consistent. So for example, I'm going to choose the height of the small house, is what it looked like to me. So I'm going to choose 20, and then I choose the same height, but of the big house, which in this case is a 35. And then I choose the roof of the small house, 9.6. And then the big house, we don't know. That's what we're trying to find. So cross multiply, cross multiply. I always do the one that has the unknown variable first. So I do 20x equals 336. Divide both sides by 20. And your answer here is a 16.8. And these are in centimeters. All right, so for number 11, it says Peyton wants to enlarge or reduce the photograph with the dimensions shown. Which of the following dimensions could Peyton not choose for his enlargement or reduction? So for this one, what I did is I put a W here because the 14 is your width, the 9 is your height, right? The smaller number will be the height. So the smaller number will be the height. The smaller number will be the height. The smaller number will be the height. Smaller number will be the height, which means the larger number is your width. Okay? Now, the only way that the picture can either be an enlargement or reduction is if both things either grow or reduce by the same number. So I'll give you an example, right? So if we match A, the height with the height, how do you go from 4.5 to 9? You multiply it by 2. So if you multiply 4.5 by 2, then that means if you multiply 7 times 2, do you get 14? And the answer is yes. So A works. Okay? It's asking which one does not work. Okay? The only one that does not work here is going to be letter B. Okay? Because if you try to go from 11 to 9, right? 11 divided by 9 gives you a number, and if I just pull out my calculator here and I do 11 divided by 9, then 11 divided by 9 gives you 1.2 repeating, right? If I take the second number and I do 15 divided by 14, then this answer should also be 1.22222 repeating, and if I use my calculator and do 15 divided by 14, it gives me 1.07, which means it does not have the same exact scale factor, which means that B cannot be the answer. Remember that it can only be similar if it has the same scale factor for the enlargement or the reduction, and that's the only one that doesn't work. Okay? For number 12, we are looking at stuff that we did yesterday and the day before. So for this one, you just have to set up a proportion, right? Bless you. So I simply do the small rectangle. I choose a number, any number I want. I'm going to choose a 6. And then I ask myself, which one matches with the 6, but on the bigger rectangle, that's an 18. And then that must mean that the 4 must match up with the x. You always cross multiply the one that has the unknown variable first. So this gives you 6x equals 18 times 4 makes 72. Divide by 6, divide by 6, you get x equals 12. And in this case, that is your answer. Now it does say to explain your reasoning. Well, guess what? This is your explanation. As long as you show me your work, that is your explanation. You don't have to write it out or do anything else for me on that part. For number 13, we have the shadow problem. These are called shadow reckoning problems. So the way we did these on Monday is I told you to find the scale factor first. And then after finding the scale factor, then you can find the value of x, right? So I can't use the base because I don't have numbers for both of those. One of them is unknown. So I'm going to use the 25 and the 6. We're going to call this one number 2. We're going to call this one number 1. So all I do is I take the number from the second triangle, which happens to be 25. I divide it by the corresponding number, which here happens to be 6. And when you do 25 divided by 6, and I did this over here on my paper already, you simply just get 4.166666666 repeating. Now this is my scale factor. That's not my answer. That's just my scale factor. That tells me that the flagpole is 4.16 times bigger than the person who's standing who has a shadow, right? So all I do now, very simple, is I take the 30, because that's the shadow of the flagpole, and I'm trying to figure out the shadow of the person. So I wouldn't multiply by 4.16, because if you multiply, you're going to get a big number, like 120 something, right? So in this case, I'm going to simply divide by 4.166666666, and the answer that I get here is going to be a 7.2, and because it is in feet, I got to make sure I write feet. So my answer for this one is 7.2 feet. Now, if you want to set up a proportion for this one, you are more than welcome to. But the way I taught it to you guys, and Mr. Rogers taught it to you guys on Monday, is we just did shadow reckoning by finding the scale factor first. But again, if you use a proportion, that would work perfectly fine as well. Okay, so, sorry, Wi-Fi disconnected. For number 14, it says, what measure for angle Z, so they're talking about this one out here, what measure for angle Z would make MNO similar to XYZ? So if you look at MNO, they already give us two angle measures, the 75 and the 55. So in order for them to be similar, the three angle measures have to be the same. So we know that this part here is 50 degrees. How do I know that? Because if you add 75 plus 55 and you subtract that from 180, that last one has to be a 50. You'll notice this one matches up with this one. So the question is, what angle can angle Z be? So your two possible answers is it can either be 75 degrees or it could be 55 degrees. Why? Because on this other side here, those are the two angle measures that we have, and that's what Y and Z can be, so you can either put 75 or 55 degrees for that one. Okay, so for number 15, it says the triangles shown are similar. Similar, again, means that it has the same shape, not necessarily the same size. If the side with length 16 corresponds to the side with 8, so I'm going to circle these. 16 goes with 8. And then I'm going to use a different color so that way you can see. It says, write a proportion that could be used to solve for y. Well, the y is the long one, almost looks like the base, right? And the one that matches with that one is the 6. So it's asking what proportion could we draw or can we write in order to solve this problem. Now notice, it doesn't say solve for y, it just says write a proportion that can be used to solve for y. So I'm going to start with the red first. I'm going to go from big to small. So on the second one, you must go big to small as well. So the big one is your y, the small one is your 6, and that's all. That's all you need to do. It does not say to solve for y. It just says to set up a proportion. Okay? And then last but not least, again, these are the ones that we were doing on last night's homework and the night before. So it says a surveyor, blah, 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 blah. They want to know what is the distance across the river. So the across the river would be this part here, which is your x, okay? So the way I taught it in my class is I said redraw your triangles so that way they're facing the same way. The big triangle I'm going to leave. The small triangle I'm going to draw down here. I'm going to put the 90 degrees, okay? This is your B, this one is your D, and this one is your C. So from B to D, it's 60, so let me use a different color, make life easier for you guys to see. That one is 60, and then this one is 30, right? So I no longer have a use for this, okay, because I just redrew it. So now I set up a proportion just like we did on number 15, and for this one I have to solve for it, right? So for this one, again, doesn't matter how you do it, you just have to match corresponding parts. So I'm going to start with the big triangle. I'm going to go big triangle, height, small triangle, height. And then I'm going to go big triangle, base, small triangle, base. I always cross multiply the one that has the unknown variable first. So 60 times x gives you 60x. 90 times 30 gives you 2,700. Divide both sides by 60. That does not look like a 6. There we go. And then when I do this, I end up getting 45 feet. And that, ladies and gentlemen, is the distance across the river. Okay, so once again, this is very bittersweet. Now that my third period is in here, right, this will be the last video that they will be watching in their 8th grade career. I don't know of any other teachers in any other middle school or high school who make videos like this, so this is me saying bon voyage, 3rd period. I wish you the very best. And for all you 8th graders, it was a pleasure seeing you guys, and hopefully you guys come back and visit me when you guys are seniors and you guys are ready to take on the world. All right, guys, I'll see you later. Adios. Peace out.